Welcome, learners. My name is Mr. Paul Chilola once again. I represent Black Slides Online Secondary School. We meet now for a lesson in physics. This is Form 3 Physics. And we are going to explore a very useful topic in physics, which is called liquid pressure, or sometimes pressure in liquids. If you are watching this video on our YouTube channel, kindly consider subscribing to the channel so that every time we upload new material, you are informed. So subscribe and hit the notification bell so that every time we upload a new material on the platform, you get the notification. If you are learning on our main platform, which is the paid platform, kindly, after you complete watching this video lesson, I expect you to complete all the assigned work, the exercises, and share your responses with me. So welcome, learners. So we are going to explore liquid pressure, also pressure in liquids, the factors affecting liquid pressure, and the applications of liquid pressure in real life. Welcome, learners. This is holiday lessons, which are going to run up to the end of the holiday, this long holiday. Welcome, learners, once again. Invite your friends wherever they may be. Inform them that the holiday lessons have begun so that they can as well join us for the lessons. Welcome, learners. So without wasting a precious time, let's look at the work that we are going to cover in this lesson. So let's look at the objectives of the lesson. What is it that we would like to achieve by the end of this lesson? Welcome, learners. So by the end of this lesson, you should be able to define the term liquid pressure. Liquid pressure. Define liquid pressure. In an exam, you can be asked to define the term liquid pressure for 1 mark. I always encourage my students not to miss a definition in an exam. So define the term liquid pressure. You should be able to explain why pressure in liquid increases with depth. You should be able to explain why pressure in a liquid increases with depth. You should be able to state the factors that affect liquid pressure. You should be able to use the formula pressure is equal to density times acceleration due to gravity multiplied by height in order to calculate liquid pressure. You should be able to explain the meanings and the SI units of the symbols P, which is pressure, density, G, and height. You should be able to describe practical applications of liquid pressure in everyday life, such as in dams, water tanks, diving, and hydraulic systems. Of course, we shall cover hydraulic systems in our next lesson. should be able to solve numerical problems involving liquid pressure. And lastly, you should be able to conduct or interpret simple experiments demonstrating that liquid pressure increases with depth. So these are the key aspects of this lesson, the things that we intend to achieve. So when you have watched this video lesson up to the end, you should be able to do these things. Welcome, learners. Let's look at the first objective, which is to define liquid pressure. For the sake of this video lesson, which is pressure in liquids, we are going to define liquid pressure as the force exerted by a liquid per unit area on any surface which is in contact with it. So liquid pressure is a force which is exerted by a liquid per unit area on any surface in contact with it. Remember, we defined last time when we were looking at pressure in solids, we defined pressure as force divided by area, or force acting perpendicularly or normally per unit area. So liquid pressure is also defined as force exerted by a liquid per unit area on any surface which is in contact with the liquid. Or simply put, liquid pressure is the pressure exerted by a liquid on the bottom and sides of its container or any object which is immersed in the liquid. So these are the different versions of the same definition of liquid pressure. So the key points from the definition is that liquid exert pressure simply because they have weight. So the force that is being referred to here is basically the weight of the liquid. All right. Another key point is that liquid pressure acts in all directions. We're also going to look at this in a separate lesson in form of an experiment. And the deeper you go into a liquid, the greater the pressure. So in other words, liquid pressure increases with depth, as you're going to see in this lesson. Welcome, learners. So liquid pressure is seen in many cases in everyday life. So the everyday examples of liquid pressure are experienced in the following cases. A diver, the one who dives into water or in a lake or sea swimming, the diver feels greater pressure when swimming deeper underwater. So when you dive into water, into the sea, into the lake, the ocean, you'll experience greater pressures as you go deep into the water. Another everyday example is that water from a hole near the bottom of a container shoots out further or farthest than water from a hole near the top of the container. And the walls of a dam are made thicker at the bottom because water pressure is greater there. These are just some of the everyday examples of liquid pressure. So liquid pressure can be demonstrated by simply carrying out a simple experiment using a plastic bottle water and a pin. So basically what you do is you make 3 small holes at the bottom. Make 3 small holes at different heights on one side of the bottle. Then cover the holes and fill the bottle with water. Then uncover the holes at the same time. You observe that water from the lowest hole, which is the hole at the bottom, travels the farthest because the liquid pressure is greater at the bottom. This is a simple experiment that can be done to show that liquid pressure increases with depth. So we are saying make 3 small holes at different heights on one side of the container of the bottle, like shown here. So these are the holes made on a container. The aim is to show that liquid pressure increases with depth. So as we go down, further down, the deeper you go. So cover these holes, these ones, and fill the bottle with water. In this case, we have just picked any container here, so which is also suitably going to work. So uncover the holes at the same time. You observe that the water from the lowest hole, so this one is the lowest hole, is going to travel farthest. If you measure this distance from the container to where the water falls there, this distance is greater than the one made by the middle hole, and the much less distance is covered by the hole on top. That shows you that as you go down into the container, into the liquid pressure increases. So they will ask you in an exam with the aid of a well-labeled diagram, describe a simple experiment to show that depth increases with the, to show that liquid pressure increases with the increasing depth. So the deeper you go, the greater will be the pressure. So this is the description, and that's the diagram there. Be able to draw this diagram properly and label it nicely, and then describe the experiment that could be done to show that liquid pressure increases with depth. Welcome, learners. So in case you are not sure, don't hesitate to leave a comment. We shall be glad to come back to you with the information relating to the joining process. Welcome to the platform, learners. Invite your friends, inform them it is possible to learn during this holiday. All they have to do is send us a text message to the number we shared earlier on. They should be able to join us without problems. Welcome, learners. My name is Mr. Pochilola once again. So in short, what we are saying is that liquid pressure is the force per unit area exerted by a liquid. That's the simplest definition of liquid pressure that we can give. And this pressure is caused by the weight of the liquid. It acts in all directions, as we are going to see in a different lesson. It also increases with depth. So liquid pressure increases with depth. All right, so based on the discussion we've just had, can you define pressure? What is liquid pressure? Why do liquids exert pressure? Does liquid pressure act only downwards? Explain. Give 2 everyday examples of liquid pressure. I want you to write down your answers to these questions and share with me. Welcome, learners. Welcome to objective number 2. Explain why pressure in a liquid increases with depth. From objective 1, we have seen that liquid pressure increases with depth. So what's the explanation for that? If you have dived into a swimming pool or a lake, you'll feel more pressure on your ears as you go deeper. This happens simply because liquid pressure increases with depth. So when you dive into a swimming pool or a lake, you feel more pressure on your ears as you go deeper. This happens because liquid pressure increases with depth. As you go deeper into the swimming pool or lake, liquid pressure increases. And you feel more pressure on your ears as you go deeper. So the pressure in a liquid increases with depth for a number of reasons. They would ask you, explain why liquid pressure increases with depth. It's because the deeper you go, the more liquid is above you. That's reason number 1. The liquid above the lake, above you as you go down into the water, the liquid pressure has weight due to gravity. So this weight presses down on the liquid below, increasing the pressure. Question, this is an examinable part for you to explain why liquid pressure increases with depth. 3 marks. So you will say the following points. The deeper you go, the more liquid is above you. That's 1 mark. The liquid above has weight due to gravity. Another mark. This weight presses down on the liquid below, increasing pressure. Another mark. So we have 3 marks for saying all these things. So therefore, the greater the depth, the deeper the weight of the liquid above, and the greater the liquid pressure. So liquid pressure increases as you go deeper, simply because the deeper you go, the more liquid is above you. The liquid above has weight due to gravity, and this weight presses down on the liquid below, increasing pressure. So the greater the depth, the greater the weight of the liquid above, and the greater the liquid pressure. So we have answered the question that says, explain why liquid pressure in a liquid increases with depth. Welcome, learners. Subscribe to the channel. Hit the notification bell. This is Black Slides Online Secondary School. We love to be with you on this platform. In case you have questions, don't hesitate to send us a message to the number that we shared before. So we can demonstrate that liquid pressure increases with depth by simply carrying out a simple experiment. So you need the following materials. You need a plastic bottle, water, and a pin. So make 3 holes at different heights on the bottle. Fill the bottle with water and cover the holes simultaneously, meaning at the same time. It will be observed that water from the top hole travels the shortest distance, while water from the middle hole travels a bit further than water from the top hole. But water from the bottom hole travels the farthest distance. This means that the pressure is greatest at the bottom because it is at the greatest depth, where more weight is exerted. So this is how we can simply demonstrate that liquid pressure increases with depth. So the fact that liquid pressure increases with depth has a number of applications in everyday life. Divers would experience high pressure as they descend deep into the water. Why do they experience higher pressure? It's because the deeper one goes, the higher the liquid pressure. The liquid above the diver has weight, more weight, which exerts on the diver below, experiencing higher pressure, liquid pressure. Another application is construction of dams. Dams are built thicker at the bottom to withstand greater water pressure. They will ask you in an exam, explain why dams are made thicker at the bottom. It's because they would have to withstand greater water pressure, which increases with depth. So dams are built thicker at the bottom to withstand greater water pressure. Another application is that water tanks are often placed at a height so that water flows under pressure to homes. So these are just among some applications in everyday life. But the key statement to go away with is the fact that liquid pressure increases with depth because the weight of the liquid above also increases. Why does liquid pressure increase with depth? It's because the weight of the liquid above increases. Welcome, learners. So in summary, therefore, we are saying pressure is lowest near the surface and pressure increases as depth increases. So the increase in pressure is due to the increase in weight of the liquid above. So why does liquid pressure increase with depth? These are questions for you to answer and give me the responses to them. Simply take a picture of your answers and share with me. Which part of the dam experiences the greatest pressure? Why does water from the lowest hole in a bottle travel the farthest distance? And lastly, why do divers feel more pressure as they swim deeper? Welcome, learners. Welcome to objective number 3, which is to state the factors that affect liquid pressure. So not all liquids exert the same pressure. The pressure exerted by a liquid depends on certain factors, which are what we are going to discuss now. So some factors affecting liquid pressure include depth of a liquid, which we just mentioned. H stands for depth or height. So as the depth increases, the liquid pressure increases. This is because there's more liquid above, which has greater weight. So one of the factors affecting liquid pressure is depth. So you need to say in an exam how liquid pressure affects, how height of a liquid affects liquid pressure. As the depth increases, the liquid pressure increases. This is because there is more liquid pressure, more liquid above, which has greater weight. As the depth increases, the liquid pressure increases. All right, so it's not just enough to say that liquid pressure is affected by height or depth. You also need to say how. How does height or depth affect liquid pressure? So the reasons which are very important for you to note down are that as the depth increases, the liquid pressure increases. As the depth increases, the liquid pressure increases, simply because there's more liquid above, which has greater weight. So, an example to that fact uses a diver as an example. A diver experiences greater pressure at 10 meters below the surface than at 2 meters below the surface. 10 meters is greater than 2 meters, so at a depth of 10 meters, the diver would experience greater pressure. Another factor affecting the pressure of a liquid is density of the liquid. Remember, density is mass per unit volume of a substance. So density is mass per unit volume of a substance, and the denser liquid experiences greater pressure than a less dense liquid at the same depth. For example, mercury, which is a metal, liquid metal, exerts more pressure than water at the same depth because mercury has much density. So the greater the density of a liquid, the greater would be the pressure that liquid is exerting at the bottom of the container. Another important factor that affects liquid pressure is acceleration due to gravity G. So liquid pressure increases as the gravitational field strength increases. For example, the Earth has an acceleration due to gravity of 9.8 meters per second square. We often round this up to 10 in school calculations. So if gravity were stronger than 9.8 meters per second square, it means liquid pressure at the same depth would also increase, would be greater. In order to calculate liquid pressure, all you have to do is simply multiply the density of the liquid multiplied by the acceleration due to gravity multiplied by height. So in this case, we are saying P is pressure in pascals, and this symbol, which is called rho, is the density of the liquid, and G is acceleration due to gravity, taken to be 10 or 9.8, and H is the depth of the liquid. This is the formula for calculating liquid pressure given its density, acceleration due to gravity, and its depth. So, an important note to take is that the shape or size of the container does not affect liquid pressure at a given depth. Pressure only depends on depth of the container, the density of the liquid, and the strength of gravitational field. So in short, we are saying that liquid pressure is affected by depth of the liquid. Greater depth gives greater pressure. and density of the liquid. Denser liquids produce greater pressure. And lastly, acceleration due to gravity. The stronger gravity produces greater pressure. So, what do you think about this? List the three factors that affect liquid pressure. Which exerts greater pressure at the same depth, water or mercury? Explain. Does the shape of the container affect liquid pressure at the same depth? So answer these questions and share with me. I'll be glad to go through your answers, and then we'll give back feedback to you. Welcome to objective number 4. Objective number 4 is calling upon you to use the formula: pressure is equal to density times acceleration due to gravity, G, times H. This is called a rho GH. This symbol here is not a P, it's called a rho. It represents density. So P is equal to rho GH, density times acceleration due to gravity times height, to calculate liquid pressure. So by the end of this lesson, you should be able to use the formula: pressure equals to rho GH, or density times gravity times height, to calculate liquid pressure. So the formula exerted by the pressure exerted by a liquid is given by pressure equals to density of the liquid times acceleration due to gravity times height, where in this case P is pressure of the liquid, rho, this symbol is called rho, is the density of the liquid measured in kilograms per cubic meter. Remember, pressure is measured in pascals. And G is acceleration, gravitational field strength, usually taken as 10 meters per second square. And then lastly, H is the depth of the liquid. So given this, you should be able to calculate the pressure of the liquid. So this equation, the symbols in the equations have the following SI units. Pressure, P, is in pascals. Remember, Pascal is a Newton per square meter. So pressure, P stands for pressure, measured in pascals. Density, rho, is in kilograms per cubic meter, and the gravity, G, has the units of meter per second square, and depth, H, has the unit of meters. So when you're given a question requiring you to calculate liquid pressure, first of all, write down the formulas. P equals to rho GH, density times gravity times height or depth. Then identify the given values from the statement. Substitute these values into the formula, which we have here. Then calculate the answer. Write the answer in correct units. In this case, pressure is supposed to be in pascals. Welcome, learners. This is Mr. Paul Chilola, your teacher on the Black Slides Secondary School platform. Invite your friends to join us so that they too can learn. Let's appreciate an example. Calculate the pressure exerted by water at a depth of 5 meters. Given that the density of water is 1,000 kilograms per cubic meter, the gravitational field strength is 10 meters per second square, and the height of the liquid, in this case water, the depth is 5 meters. So all you have to do is substitute these values into the formula. First of all, start by writing the formula down. Don't skip a formula. By writing the correct formula, you have 1 mark. Then substitute the given values into the formula. The density is 1,000, acceleration due to gravity is 10, and the depth is 5. So multiplying everything will give you 50,000 pascals. So don't leave your answer in units other than the pascals. This is the SI unit of pressure. Welcome, learners, once again. A diver is 8 meters below the surface of water. Calculate the liquid pressure which the diver experiences at that depth. Given that the density of water is 1,000 kilograms per cubic meter, and G is 10 meters per second square, while depth H is 8 meters. So substitute and simplify. Pressure is going to be 80,000 pascals. Welcome, learners. In case you're not sure about what we are discussing, send us a text message to the number that has been shared. We are going to be glad to come back to you with explanations. So the key points which I want you to note are that pressure increases when depth increases. Pressure increases when the density of a liquid increases. And you always use SI units when performing calculations. In this case, pressure has to be in pascals and not any other units. So in summary, the pressure of the liquid is calculated using the formula P equals to rho GH, density times gravity times height or depth, where pressure depends on the depth of the liquid, the gravitational field strength, and the depth of the liquid. So these are the factors affecting liquid pressure. So in summary, we have said that the pressure exerted by a liquid is calculated using rho GH, that's density times gravity times height, where pressure depends on the density of the liquid, the gravitational field strength, and the depth of the liquid. This is for you to do and share your answers with me. Calculate the liquid pressure. In each case, take G equals to 10 and the density of the of water as 1,000. So calculate the pressure at a depth of 2 meters, at a depth of 6 meters, and then at a depth of 12. A liquid of density 800 kilograms per cubic meter at a depth of 4. Okay, can you leave out this number 4 part? It's not complete in itself. Welcome to objective number 5. To explain the meaning and SI units of the symbols P equals to rho GH. So by the end of this lesson, you should be able to identify the symbols in the formula P equals to rho GH, explain what each symbol represents, and state the SI unit. We just mentioned that pressure is equal to density times gravity times height. So this formula is used to calculate the pressure exerted by a liquid at a given depth that we have already noted. So let's look at the meaning of each symbol. P in the equation stands for pressure, and that's the force exerted by the liquid per unit area. Its units are the pascals, PA. Rho, it looks like a P, but it's not a P, it's a rho. It's used for density. The mass. Density by definition is the mass of the liquid per unit per unit volume. The unit of the SI unit of density is kilogram per cubic meter. And then we have G, which is called gravitational field strength. It is also called acceleration due to gravity. And it represents the force of gravity acting on each kilogram of mass. On Earth, G has a value of 9.8 meters per second square, but in most calculations it's taken to be 10 meters per second square. So the SI units of G are the meters per second square. Lastly, H, which is depth, it represents the vertical distance below the surface of the liquid, measured in meters. So now these symbols and their SI units, their meanings, SI units in our calculation. All right, so we just mentioned that pressure P is the force exerted per unit area, and it is measured in units called pascals. The greater the pressure, the greater the pressure, the greater the force acting on each unit area. And the density is the mass per unit volume of a substance, which tells us how closely packed the molecules are. The SI unit is the kg per cubic meter, so written like this. For example, the density of water is approximately 1,000 kilograms per cubic meter. The gravitational field strength G is the strength of gravity acting on the liquid. So on Earth, it is approximately 9.8 meters per second, but 10 meters per second square is commonly used in most calculations. So a stronger gravitational field produces greater liquid pressure. So in summary, liquid pressure is calculated using the formula P equals to rho GH, where P is pressure in pascals, rho is density in kilograms per cubic meter, G is gravitational field strength, and H is depth of the liquid. So what does the symbol rho represent in the equation? State the SI unit of pressure. What is the SI unit of density? What does the symbol H represent in the equation? What value of G is commonly used in school calculations? Please write down your answers and share with me to the number that I gave you earlier on. Welcome to objective number 6, which is the last one. By the end of this lesson, you should be able to describe how liquid pressure is applied in everyday life. So liquid pressure is not just an abstract term. It's not just a theory. It has many practical applications in our daily lives. For example, in engineering, plumbing, building, and in science, we use the principle of liquid pressure to solve real-life problems. So one of the applications of liquid pressure is seen in construction of dams. We mentioned earlier on that liquid pressure increases with depth. Therefore, the base of the dam or the bottom of the dam is built thicker than the top in order to withstand the greater pressure at the bottom. This is a highly examinable point. They will ask you to explain why dams are made thicker at the bottom. It's in order to withstand the greater pressure at the bottom, since liquid pressure increases with depth. Another application is in water supply systems. You will see in most cases, if you live in town or anywhere, water tanks are built on higher towers. You see the water tank at a higher level. This is because the height of the water increases, creates pressure that allows water to flow through pipes to homes. So schools and hospitals without the need for pumps in most cases uses this technique. So it ensures a continuous water supply. Another one is diving and submarines. As divers or submarines go deeper, they experience greater liquid pressure. So divers use special equipment, and submarines have strong, thick walls to withstand the high pressure. So the application there is to ensure safety and water. Another application is seen in hydraulic machines. This is going to come as a lesson on its own. So hydraulic brakes. Examples of hydraulic machines are hydraulic brakes, hydraulic jacks, and hydraulic lifts, which all use liquid to transmit pressure. According to the Pascal's principle, which we are going to look at in a separate lesson, pressure applied at an enclosed liquid is transmitted equally in all directions. So the application there is that it is used to lift heavy loads and operate vehicle braking systems, hydraulic systems. Another one is seen in water stored at a higher level flows under pressure to farms and communities. That's water towers and irrigation. So water stored at a higher level flows under pressure to farms and communities. This allows water to reach areas that are lower than the storage tank. So some important applications, in summary, therefore, of liquid pressure are seen in building dams with thicker bases, supplying water through elevated tanks, designing safe submarines and diving equipment, operating hydraulic machines such as jacks, lifts, and brakes, and distributing water for irrigation and households. So the key points in this objective is that liquid pressure has many practical uses in engineering and everyday life. Understanding liquid pressure helps us design safe and efficient structures and machines. So lastly, I would like you to answer these questions and share the answers with me. Explain why dams are made thick at the bottom. Why are water tanks placed on higher towers? Explain why marines are built with thick walls. Name 3 hydraulic machines. State 4 practical applications of liquid pressure. Welcome once again. My name is Mr. Paul Chilola. Expecting to see you soon. Remember to complete all the assignments, the questions that we have in this lesson, and share with me the answers. Bye-bye for now.